Hello everyone, I want to welcome you to my YouTube channel. This is Steve coming back with another video for you. So in this example, I'm going to be showing you some assembly language tools you can use for your projects. And also this is going to help us move forward with that machine language project very soon. Came across this by getting some information at lemon64.com, so I want to thank those guys for reference and show me where these tools were located. And then I just had to spend some time looking at them. Now, I'm not fully versed in all of them yet. I'm still looking at a lot of the things, and there's still things I'll be learning, but I just thought I would share it with you for now because this is some really cool stuff. Let's get started. Okay, so first, before we get started, we're going to need a game to actually do some coding with. And this is one I just found. I actually own this game. It's actually called Technocop. And this is just actually level 2 here. I wanted to show you guys this. We're going to basically use this tool to look at some of the sprites, and we're going to be able to look at the code. And eventually, once I'll be able to do some more disassembly in this game, we'll be able to actually start making changes to it. We could probably make a few simple changes for now, but I just wanted to show it to you. So give me one second. Okay, so I'm back, and this is the tool that we're going to be using right here. It's called Infiltrator, and this is version 1.0. Now what it is, I currently opened up all the screens, but if you're clicking on these buttons right here, you're going to get each screen. Like there's the sine wave, for example. Here's the CNS. Here's the sprites. And here's the hex decimal for the text in the game and stuff like that. And then down here at the bottom left is the disassembler. And this is going to allow you to see the actual code in the game, and we'll get in all that stuff here very shortly. So. Okay, so to get this started, first of all, to help you guys, what you're going to do is you're going to go in device once you have a game running here, and you're going to click on the snapshot menu here, and you're going to click on save snapshot image. Now, for some reason, mine are not loading right now, or they're behind the screen. My computer's acting real funny, but it should pull up basically a window like that. Oh, I think it's because I have it on pause. Yeah, I had it on pause here. So there's the window. And then you just basically go in here and you create a name. I just called this one, what did I call it? Technocop ASM is what I called this one. You could go and you could just create like a different number or whatever. So we have a second example. I'm going to pause this so I don't lose anything there. And then now once you have that, you just go over to Infiltrator and you click on Vice there. And you're just going to look for that file. For example, 2 is right there, and we can open it up, and it'll open it up in here. But earlier we already did ASM, so I'm not going to do it for now. But once you do it, it'll just preload it here. And then that way, it now gives you access to everything you can see in the code. So we're going to go over these one by one. I'm going to start in this corner first. And by the way, if you're curious, I like to overlay my windows so it's easier to get to them. It's just a technique I learned many years ago when at work and stuff like that. And it's easier because you just click on them like this and you're instantly switching out to those windows. So anyways, let's start with the sine wave here. And load it up here. I'm going to move this one over since it's kind of large here. We can kind of expand it if you want for a minute. What this is actually doing is it's keeping track of all the sound waves that are actually being converted into sound waves in your code. And these are the memory areas inside of the actual program here. So we look over here, we can see one at 0B11. We could set this one to like this range, which is exactly where we have. And you're going to hear some really weird sounds. It's going to basically take the sound that's coming across in code and converting them into sound waves. I have no idea how to play the music in the game yet, but that might come later. It may have something to do with this bytes per second or something. But let's, I'm going to turn this volume down because it's kind of loud and creepy, but you're going to hear it now. You just kind of turn it up there. You can also save it as a wave here. So here it goes. It goes through pretty quickly. And then you just go here and you could save the data as a wave if you wanted to save some of the sound. This way you can go inside of memory and you could save actual sound locations. So I thought that was kind of interesting. Okay, so next we got the CNS, and this is the actual character set, which we already have on the screen right here. So I'll just expand this one a second. And I've already predefined this so that we can kind of match closer to what we're seeing over here. Otherwise, you got to go in here and you got to change all these values. So what you're basically doing, you're just seeing there's tabs here. This is for single color. If you want to see the character set in single color with basically only two colors, the foreground and background, you can see that. But if you click on this button here at the top, it says Screen and Character Set Multicolor. This is where you get all the different colors, and you can go to these tabs here, and you can change the individual colors just by selecting them there. But this background is not red, so we're going to put this one back the way it was for now. Oops. That's the one right there. It's kind of close to the original, but not exactly. I just wanted to kind of show you that. And then these are the memory banks in the character set areas. Oh, I'm sorry, these are the memory banks right here. You can go through and you can change them here. You can see anything in your character set all the way up to right here, and I think this might even contain the actual letters and stuff. Actually, it won't show them. That's right, because that would be in basic, so you wouldn't see them here. But anyways, if we change this back, you can kind of figure out where the code is for the actual game and stuff like that. Here's some. Actually, I'm glad I did that. So now we can kind of see them a little bit better here. I don't know if you could scroll this or not. Okay, so this is like one area of character set memory here, and this is going from 4000 hex to 47FF. Now, what does that mean? Let me show you something real quick here. I'm just going to pull the calculator up. For those who are kind of new to the stuff and don't get it, because I know I created that one video, and it was all machine language hex, because, I'm sorry, semi-language, you're going to write in hex, because that's how, it's an easier way to convert it from decimal into a numbers that are easier for the computer to reference. It's just a hex converter built into Windows 10 if you have it. Now, Windows 7 and whatever versions have their own different versions, but I'm using Windows 10, so we'll stick with that. So you just click on these buttons here, and you can do the conversion. If you want to convert from hex to decimal, you just click on this value here, and you're basically taking the number 400, and you can see that's memory location 16,384 through 47FF, 18,431. So that's what those memory locations are for. So that's how you can convert it to figure out where in the Commodore 64 mapping the C64. And as always, I like to show these to people. This is the book I'm referring to, Mapping the Commodore 64. So you can go in and you can look up the memory locations in there. And you can see there's more character sets here. As I click on them, it's going to see what's in those areas. And this is just what's loaded in this current level, basically. You can kind of see they're all pretty similar to what you're seeing here. As you go through here, you're going to get different ones, of course, because it's going to be looking at different areas of memory. So the program is smart enough to figure out where all the character sets are, and it does so much more. I'm excited just to show this to you, because it's probably going to take me a good while, probably a good month to learn this thing. But I've learned it enough to really show this video, at least. Okay, so that's the character sets. Next, if you want to convert anything into bitmap, you can use this one. Now, I don't really use this unless you want to basically be able to take pictures that you know where they're at in memory and convert them into a bitmap. I haven't really found any usage for it yet. You could basically convert this into a bitmap. If you go to multicolor, you'll get the multicolors here. Oh, you got to click on them here. You'll see them in multicolor now. See the hand's kind of in multicolors. It's kind of hard to see it. There's to see it better there. You can go in here and you can change the colors as always. And this is going to change the appropriate backgrounds for where the multicolors are. To kind of, if you wanted to match it to that, you just basically look at that. What I like to do is I look at that, for example, and just kind of try to see which color might be closely matched to it. If you don't have a red, you could also go in here, and you can also do custom here too. I notice there's a custom build, and you can click custom like that. And you can get more predefined colors kind of closer to what that might look like. And you can kind of see how it's easily going in and it's altering those colors. That's pretty close to it. But anyways, wanted to show that to you. So that, and then what you can go here and do, you can export it as a BMP by clicking on this, and now you can convert this into a bitmap, for example. Let's just say I wanted to see that in a bitmap, techno pic or something like that. And I'll save it in there where I can find it real quickly here, like pictures, techno pic. Now let's go to my folder here. Just saving some time here again. So you just basically look up the folder, it's in pictures, and click on TechnoPic, right click it, and you can just say open with, and you just click on paint. It should open it up. So it basically picked up that area, so I probably didn't click on the right one or something. It actually picked up this is what it did. Actually, let me just double check something here real quick. Oh yeah, I forgot to select the right picture. So if I selected that one, it would have saved that one, so I clicked on the wrong one there. So let's just say Techno Picture 2, or Pick 2. Then we'll just go back to our little window here, and it should show up as 2. Right click it, open with, paint, and there it is. So now you can actually see you've got the actual data here. So if you wanted to go in here, you could actually go in and alter it and whatever. But just wanted to show that to you. So next, we have the sprites. This one's interesting. Everybody loves sprites. So I already predefined these closer to what we're seeing over here. So as usual, I'm going to enlarge this for your viewing pleasure here. It's picking up the memory locations again. So once remember, always if you use that calculator here, let me make a lot of room here so I can try to sneak the calculator in here. So I have to keep looking for it. Yeah, that's good. I can kind of reach it there. If you click on here, and then of course you can convert whatever 5,000 hex is, and that's 20,480. So you know it would start at memory location 20,480 if you needed to convert it to decimal. So you can see that's some of the character background there, and these are the exact areas where you can find it. And once again, you can just scroll through the memory areas to get all the sprites that's actually in this level currently. And it's also going to pick up some of the car. You'll see that down here. So you can see some of them were the men down here and some of the bad guys and stuff like that. There's some of the car right there. That's actually the first part of the level. I played it up to the second level. I find the second level far more interesting. But yep, and you can once again go in and change the colors here to try to match what the original is. I just set this one to custom since I just defined it myself to kind of get closer to what it looks like there. Single color, standard mode versus multicolor. So yep, there's that part. And there's really no saving you can do on these though. They just save the bitmaps. Oh, actually you can. I just now saw that. So yeah, I'm sorry, I missed that. So right here, export as BMP. You can just go do the same thing. You can create the file. I won't do it again, but you can create it here and then upload it to your bitmap or your P. Just pausing to save time. Okay, so the next thing we're going to look at here, we're going to skip over this one because this one's we're going to be using a lot longer. We're going to click on hex. And this is going to show you all of the actual text in the actual game. So if you just click on these arrows here, or if you want to predefine those areas, you could look in those areas, but there's probably nothing in there. I just kind of go through here, and you can kind of see some of it picking up here. See some of the words, suspect, question, which is exactly what I'll have in this game itself. And you can scroll down through them using the page up and page down keys, to move it quickly through the code. And all this is doing is it's looking at memory from hexadecimal standpoint. You have 16 bytes. You also have 32 bytes if you want to spread it out more. So I have to enlarge the window a little bit there. Kind of make it easier to kind of see longer streams of text. And this is a conversion. You can convert over what the hexadecimal areas will look like if you needed to add it to example for like a semi-language listing. This one I won't go into yet, but the main thing is these ones, the 16 bytes versus 32 bytes view display. And these hex values here, you can convert them with the calculator. Basically, they're just converting as AXI or PETAXI that will show up in your computer's memory. And maybe we'll try to find an example in the code for them later. Okay, so I'm going to come back to the hex here in just a minute. Before we get to that, I wanted to show you some of the things that's going on here. So we're basically, when we click on Vice here and it loads into memory, it's going to show the information in the window here. As soon as you load it in, it's going to get the preloader or what accumulators are, and it's going to show you the memory range of what it loaded in and stuff like that, and where the folder it found it and stuff like that. You can also convert it to a PRG here by clicking on PRG. Once you have the code disassembled down here, which we can go over, you can click on PRG, you can convert it. Now I haven't got this successful to work yet. There's another tool I'm using actually for that, which I'll probably show you that here in a minute. It's actually over here, it's called Regenerator. But for now, we'll go right into this one. So I just wanted to show you that's how you basically save the files once you're done with them. You can set it as a binary here for bin or PRG for program to load directly in the device. Okay, so next, of course, we got the grand finale, I like to say. And this is the disassembler. This is where you're going to find all the actual code in the game. Everything we've been talking about thus far, you'll be able to find in here. So if we wanted to look up for the sprites, we could figure out where the sprites are. I'm going to shrink this down. Anyways, what I was trying to do is I was trying to see if I could search it by like an individual field, for example, to see if I could locate the text in this actual game itself. But apparently it doesn't look like you can search just by, like if I said in 3980, it's not going to find it unless it's actually in here in the code somewhere. So I'll show you some other techniques you can do to kind of speed up things though. So this is the disassembler. Remember, we just clicked on this DIS right here to get that window. And then now we're going to be looking at the actual source. So this is the source for the actual game. What's really cool about this is they break it down. You can look at the graphics, you can look at the interrupts, you can look at the sprites, you can look at the music or the sound, you look at the screen RAM, the color RAM, clear screen, that's kind of cool, self-references, and a quick search, which I was trying to use the quick search here, but I couldn't get it to work. You can go in here, you can right-click on code, and you can instantly jump to RAM addresses here. Oh, not sure why that didn't work. Jump to selection. You can go right here, you can click on these and it'll kind of jump around. You can also scroll the window over here on the right to see the code. So I'm going to show you what these are all about over here now. Now these are actually if you're needing to find areas in memory that aren't really making sense. They're what they call jams and stuff like that basically can usually stop your program. And there's BADs. These are basically addresses that are, I think they're not referencing anything. And those are the subroutines. So we'll start down here. So I mean, because there's a lot to go through here, and I really haven't got a whole lot of time where I almost want to waste the video going through everything, every single little thing here. But here's where it actually starts here. So if we click on here, 0B52 SCI, this is a set interrupt. This is where you can see some of the actual where the game code would actually start at. SCI is a set interrupt, and this is kind of like setting off the game. You can always, if you can find an SCI somewhere in your code or set interrupt, you can more likely usually find the start address. But one of the other guys was giving me a tip. He said look for the reset address, and that'll make it a lot easier. Or that was called the reset vector, I think it's called, helping you to quickly find out where the program might launch from. So this assembly takes a lot of time, but these are actually breaking down the actual code location. Notice as I'm clicking on these, it's changing where it's finding all these references in the code, basically. And this is pretty massive. I mean, this breaks all the actual functions or all the opcodes down in the actual, assembly language. So this is why when I hit SCI, you're seeing all the SCIs here. And as I scroll through here, oh, excuse me, you can see them all right here. And it's showing you all the actual references of, how they're broken up. So we can spend a lot of time in that. This is a lot more for disassembly if you're trying to find something quickly in code. The really cool ones down here are like, here's the CIAs, for example. And once again, if we need that converter, we can pull that converter back up right here since I got the calculator for those. I'm not really versed in hex all the way either, so I use it a lot. So if we go in here, we just type 0B67. It's decimal 2919. And that's where it's finding these actual locations. DC00. 56320, so this is more likely where the joystick routines are in the actual code. And once again, you're just jumping through code segments to find out where all those occurrences are happening at. And that's CIA1. There's also CIA2. I think that's the joystick 2. And this is where it's all finding occurrences of CIA2. And remember, as always, everything is coming from that map in the Commodore 64 book. everything in here. So if you just look up 56320, it'll be in decimal here. You can see this is where it's getting the CIA routines right here. See it says CIA there? Oh, where's my camera right there? There's 56320 and 56321 is right there. So that's a good book to really find out what's going on with these codes and stuff like that. So other than the CIA2, we got graphics. These are all the graphics routines. This is the actual, I think this is the background color. No, this is 53, yeah, this is the border color. So D020 is the border color. That's when you're changing the border colors. So if you see there, they've got like a 36 hex in there. And 36 hex is 54. So it's basically putting a 54 into these locations. Or I'm sorry, it's a 1. So if we go over and pull up Vice real quick here. Let's just say we wanted to see what color that was. It's like a white. And you can see that's what it has right here in the background. It's like a white around it there. Or actually that might be in another part of the program. But remember, it's looking at all the code in the actual game itself. So here's D011. I also didn't mention, but these hex codes are broken down in the book too. To pull it back up here real quick just to show you. So what are we looking at? D011. You can look them up by the memory addresses. So D011 would be over here somewhere. D011, 56, 53, 265 right there. This just says D011. And this is the vertical fine scrolling. And these are the bits, by the way. You have to know how bits work. You set the bits here. And the bits would control fine scrolling, depending on which bit set, the graphics mode, extended color mode, or whatever is actually being activated. And then that's what this is actually doing right here when we're clicking on the D011. This is showing where it's finding these occurrences here, and we have a 7F in here. So we could probably go ahead and convert this if we needed to figure out what it was. 127, and if we converted that down, we might be able to figure out which byte is being converted. Oops, not sure why that didn't work. Minus 127. Oh, I'm converting in hex. I need to go over here to the decimal, excuse me. So remember, if you're clicking on these, it's switching them. Here's binary also if you need to convert into binary, decimal, or whatever. Let me just clear this out. Decimal, 255 minus 127, was it? Is 80. Or 128. 128? Yeah, I guess 128. But that's how you can convert them down to figure out what bits are being set. So 128 is bit 7. And if I looked at the book again here real quick, these are 11. Giving you kind of a lesson here. So on 53, 265. Bit 7 is enable high bit of raster compare register. So apparently this one is controlling the rasters in the actual game somewhere. And you can see these are all the ones bitten, and these are all the ones divided down by the graphics in the actual code. And then to go over those, we also have the interrupts here. So if we hit the interrupts here, we're going to break down where the interrupts are all stored at. So we can figure out, like, maybe there's a walking bad guy or something. We could probably figure out where he's walking at and stuff like that and alter him or something like that. So we also got the sprites. So we see where the sprites are being preloaded in. I'm going to start with this one. This is 53248. This is our guy's horizontal position, and this is his vertical position. So this is kind of where it starts at there. You see it's at 62. So if we converted 62 here, for example, 62 is 198. And I'm just going to pull this up to show you something real quick here. Pause. So I quickly pulled up a little sprite example here, just a simple little square here. So if we needed to figure out like where this value was coming from, for example, in this code here, where it says 62, which we know is 98 here, and we know that that's actually going to be stored in D000. And again, if we needed to convert it, remember in 62 for a second, it's 53248. So 53248 come, what I said was 62? 48, right? 98. So we could go here and we could just sit there and type 53248, comma 98. And you see that's kind of like a starting position for a sprite somewhere on the screen. That's exactly almost where the sprite is located. If I had to squeeze this window down here, for example, like that, you can see it's almost identical to where he's sitting at in the screen there. So that's kind of like where our sprite starts at. So we could go in here, we could alter and switch his location, moving down here or whatever, and do some funny stuff. Or if we wanted him to get past a certain level, we can move him over to the other side or something like that. So this is kind of the stuff you could play with. We're just basically going through and we're looking at all the registers here. And like I said, it's just amazing. It breaks them all down and it instantly switches the windows over here to where you're looking at that part in memory. And that's all for the sprites. And then we got the music. You click on these. These are the registers. Once again, converting D400. Use our hex calculator, or we can use our book. 54272. And I should use this one, D418. 418. So that's 54296. So this is actually the volume control right here. So they set the volume control to A, which is 10. So basically setting it to kind of an even volume level. And then these are going ahead and these will change the actual sound register. So you could actually change some of the sounds by changing this load accumulator value above it. This is going to allow you to control whether it's sawtooth, waveform, random noise, or whatever kind of sound you want to get. So you could go and you could find out which one you're looking for just by looking up the actual register and changing it. Now, once you've done all this, you have to go through here and you have to actually disassemble it. There's a disassemble button here when I clicked on this tab here, or you can just scan through the code here, and you have to set the memory registers right here. So if I needed to set, you know, that's not the start of it, but let's say that was the start of it, to however far you wanted to disassemble to. You would do that, and you would just basically click on disassemble here. It would take a little bit of time here. You'll see it basically just doing disassembles of code. Now I use another program, like I said, over here. It's called Regenerator 1.7 to go ahead and allow me to save them. And so it just saves them into the task assembler. I haven't figured out how to get them into Vice yet, but there's other ways you can do this. As we're going up through here and we're changing something, let's say we went through and we changed like one of these registers, for example. Let's say we wanted to go in and change D4112 off the top of our head, 54290, and looking in our book real quickly here, since I do not have these memorized. It's a voice 3 control register, so let's say we want to change like the ring modulation, because this one is currently set to 81 hex. Whoop, where did my little calculator go to? That moved around a little bit. So we can go in here and we can look up that register. Let's say it was 81. So we can go in here, we can switch this to 81 and just look it up. And we can see it's 129. So if we need to convert that down, you just subtract it from 255. That tells you what the bit's going to be. So they just set the decimal and just hit the escape key. 255 minus 129 is set to decimal 126. So there's probably several bits being set. Maybe the waveforms being set and other different values are being set. So I'm showing you that to show you if you wanted to go in and you wanted to change something here. Let's say you went in and you wanted to change this or something. You could go into the actual game over here for now, and you could pull up the monitor here. May have pulled it up somewhere else. Give me a second. Moved it on the other screen here. So if I go here and I open up the device monitor and I click on the assembly window, this is the same thing we're looking at in code here. If we scroll down to 091A, let me pause for a second. Okay, so I quickly moved inside of the assembly window so we could get to that area so we don't have to sit there and scroll through and you have to waste more time with that. So right here we can see 0921 is showing load accumulator 00808. You can see that's exactly where that is. So we could go in and we could change that here. And to change code in here, so 0921, I'm going to remember that for a second. You just go here and you just type in, first if you wanted to see it, 0921. You're looking at that memory register right here and you just basically say A, and then you just type over that memory location 0921 and whatever value you're going to put load accumulator. And let's just say we wanted to change it to a gate or something like that or whatever. You just put the value like that. And instantly, it's already altered that memory location to a 1. So if we go back here in the game, you might have to reload it or something. It might change the actual sound. I don't think it'll change it on this level because it could be occurring anywhere in the actual game. It's just more about disassembling it and figuring out where everything is in the actual game itself. Let's see if I have this thing loaded up for a second. Oh, I gotta shut down the windows first. So anytime you want to get back to it, you have to actually close this window back out, or it's not going to know the game's run. Now the game's run in real time here. So we might have changed something, and we got some kind of crash going on there or something. There's the gun. So I can't really tell what it's changed in the actual game, but you can kind of see. You can go in real time and you can change stuff there. And I'm getting some kind of a crash or something there. I don't know what's going on there. This is a hacked version, so it's probably doing some weird stuff. But yeah, that's how you can go and you can alter the code. Okay, so I know this video is getting long, but I really want to show you there's a lot of exciting things. In addition to the SID, we have screen RAM here. You could go in and figure out where screen RAM locations are being changed and moved around and stuff like that. It shows you the indirect jumps and stuff like that. A lot of cool stuff. Color RAM. This is like the background coloring on the screen or screen memory, for example. You can see the individual areas that are being changed by the screen background coloring. And sometimes with that, you can figure out where the character sets might be plotting into the screen and stuff like that. Then we got clear screen. There's no clear screen found in this one. And there's self-references. I have no idea what that one's for. And like I said, there's so much involved in this. Looking at the BADs and stuff like that, and just different ways you can move, or you can just go here and you can scroll through memory itself and see everything, your whole computer's memory. It breaks it down by byte locations. I mean, this is probably one of the best assemblers I've ever seen. I just wish they had more of an option where you could really save it, because if you save it here, it saves it. It's open. If you click it here and you're trying to save it, for example, like export it, what did it do there? Yeah, it exports it. I don't know what kind of value. I know it kind of does something really weird here when you try to export it. It exports it in some kind of an export file, it's called. And I guess somehow there's a way you can convert that over to Vice, but this wasn't really meant to work with Vice except for loading in. This is why I use this one more, Regenerator too. When I want to save stuff, I can save it here, and I could actually save it directly and load it into the Disassembler, which is another assembler you can use to look at code and alter it. Or you can just go, like I said, over here. Once you change it here, you could use the monitor and change it and vice versa and stuff like that. So I think that's pretty much covering everything. And the options down here, I didn't show this, but you can go and you can set comments in the game and stuff like that. If you wanted to go here and, for example, you wanted to add comments down here or whatever, you could add comments into it and stuff like that. And like I said, this thing has so much you could do into it. It just goes on and on and on. You can change the font size. It's overwhelming to try to really tell you everything in here because there's just so much involved. But I think it's a really good way when we start doing the machine language project to really start breaking down things and figuring out how the professionals do it instead of trying to, I like to say, rely on old bad techniques that I've learned over the years. Rather than we could just go right into the code itself and say, hey, maybe this would probably be something be better to use it. Like, for example, if we need to look up like screen scroll routines, let's look that up. So I quickly converted back again here. So 53270, this is where the screen scrolling is actually found. And I think this is the horizontal screening because the 53265 is the vertical scrolling. So when you're setting in horizontal 53270 bit 0 to 2, it enables fine scrolling. So, for example, we have D016 here, and we go and set this to graphics, and we look up D016, we could see possibly where it's altering and changing the scrolling, and going ahead and use a monitor again, we could probably go in and change some of that stuff. Well, I was just not playing with this, I just now figured out how to save it as a binary file. So actually what you have to do is you have to go ahead and you have to set this little ripper value to wherever the start of memory is. I just use 0900 as an example. And then once you have this set for the end range, then you click on binary and you click on export this time. It actually will save it as a binary file. So now we could actually save it and run it and load it in Vice. So that's kind of cool, I think. So I think that's pretty much everything I could show you with this that I have, accumulated. Oh, the last thing I was going to show you was this. I almost forgot to show this, but this is the actual PDF for the Infiltrator. This is where I learned how to use it a little bit quicker. So here you can download it just by going to looking up on Infiltrator in Google or whatever. I'd probably type C64 Infiltrator to find it. And this has got the table of contents. It's really broke down, really awesome. They're using that game example here, and they show you how to go through and actually hack it and look up the sprites, which is how I learned how to use and do it with this one. The Sine Wave. It breaks everything down in code, the pictures. I think it's an awesome documentation for the actual tool itself. I haven't really had time to really go over it, but I've learned most of the basics, which is what I've showed you here. But there's so much more it can do. Once we start getting into more advanced, you can go here and you can set up something called a code shaker and a legal shaker. I haven't really showed you all this, but it explains what they do here. Quick search. But you can get that here by going into the actual Disassembler, for example. And here, and you right-click it. Actually, I probably didn't show you all these, but you can right-click in code like here with your mouse, and you can get to legal shaker here by clicking on it. I probably have to set it up or something, but you can also jump to locations here, so if you wanted to jump around quickly in memory, you could do that too. Just kind of the quick techniques they build in. You can bookmark stuff. And yeah, like I said, I didn't really want to go into a lot. You can also copy. This is really cool too. You can actually copy this code here. So if I wanted to copy it, I can click copy there. And if I needed to open up like Notepad, for example, I could instantly copy it if I needed to use it for something. So a lot of stuff you can do. So anyways, guys, I hope you guys enjoyed this tutorial. I know this kind of went over a lot of stuff, but I didn't want to make that an hour video, so I tried to go over that as quickly as I could. But as we go through the machine language project, we'll be using Infiltrator or more in Regenerator, of course, as we start, getting more into really how to write really advanced routines and stuff like that. So I'm really excited about that push forward and really learning more about, taking apart the real professional games out there. Keep in mind, this is any games you find out there from Double Dragon to Predator, Commando, anything you can see in an actual game, you can actually disassemble it. So you can actually go to and download them online. Just look up Commodore 64 ROMs. And there's one called C64 Base, I think it's called, where you can download a lot of the ROMs. And I didn't want to waste a lot more time going back with it, but I just wanted to give you that information. And I hope you guys enjoyed this. And yeah, we'll look forward to some more videos coming soon. Thanks for watching.